Okay, we've been talking about the periodic table for quite a while now, and I really want to make sure that you guys get some certain concepts down. One of the things today's quiz is going to be about is atomic size, and it's actually going to be about how protons and electrons, how the way they act in the atom affects basically three different things: atomic size, electronegativity, and ionization. All right. So the first thing I want to talk about is atomic size, and the weird part about this, and the reason a lot of people I think get a little kind of strange. It makes sense as you're going down the periodic table like that. It makes sense that things are going to get bigger. What happens? Well, every time you go add on another orbital, that orbital is further away from the center, so it's going to get bigger. The atom's going to get bigger. But the weird thing that happens, and this is, I think, that's something that I always found a little strange, is that atoms actually, the size increases as you go from right to left. In other words, as you go from lithium, beryllium, boron, the atoms are actually getting smaller as they're adding more electrons on. Now, that's a little hard to understand until you think about this, is that all of these guys in each row, in this individual row, say here, all these guys basically are working on the same orbital. And that orbital is roughly the same distance away from the nucleus. But what happens is, as you go from lithium to beryllium to boron to carbon, as you go, you wind up having more protons in the center of the atom, and those protons are able to pull harder on the electrons that are on the outside. So just keep in mind, as you go from left to right, the atoms get smaller. As you go to top to bottom, they get bigger. Okay, well, that's pretty good. Now, electronegativity and ionization, they're two different ways of describing the same thing. Basically, they're about how hard the protons pull on the electrons. They're about the strength. I keep on giving the analogy. It's, you know, you've got a baby, you've got me, and you've got Rob Gronkowski. Well, the baby is very weak. I'm kind of moderately weak, and Rob Gronkowski is very strong. Okay? The bigger you are, the harder you pull, the stronger you are. Okay? So generally, it makes sense if you think about it. If you are going across, you're going to pull on your electrons a lot harder. Okay? Why? Because, for instance, lithium here has 3 protons and then 3 electrons. Beryllium has 4 protons and 4 electrons. Boron has 5 protons and 5 electrons. What's happening here is the more electrons and protons you have, the harder you can pull on your atom, the harder you can pull on the electrons that are there. The other thing, though, and this kind of makes sense if you think about it, is that going up the table from bottom to top, electronegativity increases. And that also kind of makes sense because hydrogen, those electrons are right there. They're only 1 orbital away. Lithium, there are 2, so the electrons are, those outer electrons are a little bit further away. All right, and then sodium has another orbital. There's 3 orbitals, so that the electrons in the inside sort of block the electrons further away out. So the further away you get, the bigger the atom, your hold on those electrons is going to be a little weaker. So the strength of electronegativity increases as you go from bottom to top, and it increases as you go from left to right. And the same thing is true of ionization. Ionization is the energy necessary to pull away electrons. Okay, so let's actually try to put some of this knowledge into practice. All right, let's take a look at the first problem. I'm going to work you through the first couple of problems, or one of each kind of problem, then you're going to have to do the rest. All right, now to start off with, and I did something. I'm going to kind of put it back to where it was so you can see my thought process. All right, so let's take a look. All right, well, we're trying to compare chlorine. All right, so what I'm going to do is I'm going to put a diamond around it. We're going to compare chlorine, which is right here, argon, which is right here, sodium is way the heck over here, and silicon, which is right here. Right? So we want to compare them in terms of, what are we comparing in terms of? We're comparing them from largest to smallest. So remember, atomic size increases as you go from right to left. So in other words, the guy who's furthest over on the left is going to be the guy who's going to have the biggest size in each row. So that means, if you look at this, that means sodium is going to be the biggest. And then the next guy, silicon, is going to be the next guy. So he's the next largest. Right? Remember, they're going to keep on getting smaller as you go across the row because you have more protons pulling on them. Chlorine is the third largest. And then the smallest of these guys is going to be argon. Okay, so that's how that works. All right. Now, if we were going the other way, if we had guys that were all in the same row, that would tend to be, if they were all in the same column, I should say, the guy furthest to the bottom would be the largest, and the guy closest to the top would be the smallest. Okay, so that's how you do size. Now, let's go and let's take a look at electronegativity. I don't think I do actually ionization energy, I just do electronegativity. And let's do this one. This one here is actually a little tricky. So I'm going to show you how to do this one here. All right? Because this one here is a little bit more all over the place. Now remember, we're trying to figure out where the atoms are. Okay, so let's just take a quick look. All right? We have francium. All right, so let's put a little box around francium. That's way the heck down here. All right? We have tungsten, that's W, because it's a metal that has been discovered by the Romans, so it's in Latin. We have fluorine, and we have silver. Okay? So you have francium, tungsten, fluorine, and silver. Now, if you take a look at them, we're looking at electronegativity. Now, remember, electronegativity increases as you go from top to bottom. So, in other words, electronegativity right here, okay, is highest in the top of the level, and it's also highest over here, okay, at this side. So, if you take a look at fluorine, there's no question about it. Not only is it the highest, but it's also furthest over to the right. So, it's going to be the most electronegative. All right. The next guy here, you notice this guy's both higher and further to the right than tungsten. So this guy's going to have more electronegativity than tungsten. All right, it's going to pull on the electrons harder. So that is Agius. Oops, that was the wrong one. Sorry, I did the wrong one, guys. Fluorine is the highest electronegativity. Then this tungsten is the second. Silver is, oops, I'm having a bad day, guys. Silver is the second highest. And then if you take a look, then tungsten is the third highest, and the least electronegativity is going to be our friend francium. So that's how you do those. The last part of this is you have to go back and remember what I said, what is required, which one is which, electronegativity is what is atomic size, what is ionization energy. If you don't get what atomic size is, you're really not being able to read the instructions. Okay? So, folks, you need to do this. You're getting points on this, and hopefully this helps.